Welcome, everyone. In this session, we have Shailvi Wakhlu, Senior Director of Data at Strava, preventing, diagnosing, and curing bad data. Just a quick note that please post your questions to the Q&A box instead of the chat. Shailvi, a reminder to start your timer, and then off to you.
Awesome. Thank you so much, Catherine. Thank you all for joining today, and welcome to the Women in Data Science Conference, Puget Sound. My name is Shailvi Wakhlu, and I go by the she, her pronouns. In my talk today, we will take a journey to explore bad data. Together, we'll understand how to prevent bad data, how to diagnose it, and how to cure it. By the end of the talk, I hope you feel empowered with the right tools to make sure that bad data never gets in the way of great business outcomes. A little bit about me. I work at Strava, where I'm their Senior Director of Data. Strava is the leading social platform for athletes and the largest sports community in the world, with over 80 million athletes in 195 countries. So let's kick off our main topic for today and start by answering the question, what is bad data? Bad data is any data that is inaccurate, incomplete, or misleading. Such data can also be referred to as low-quality data, and it can show up in a lot of different forms. All of it can eventually lead to bad decisions. Just to be clear about what bad data isn't, data that shows you something that you don't like seeing or you don't want to see, that doesn't make it bad. If the data is accurate, if it's complete, and if it isn't misleading, it is not bad data. So a few common examples to illustrate how you might notice bad data. I will take the example of you looking through a few trusty dashboards that you rely on to make decisions. First, you check a dashboard to check the total number of sales for your product last month. The dashboard says you had 2 million signups, but you're already aware that the sales team has recently been celebrating hitting a 2.5 million sales last month as a milestone. Which one is it? One of those two pieces of data is inherently inaccurate. Next, you check the dashboard that identifies the number of sales broken down by country. Here also you notice something peculiar. You know your product is mostly being marketed in North America, so it makes sense that Canada and Mexico show high number of sales, while European and Asian countries are not as big. But it feels a little suspicious that US, which is your primary market, is such a small number in comparison to Canada and Mexico. Your product is, after all, made primarily and sold in America. So you know intuitively that USA should have a much higher number of sales. Something is going on and your data is probably incomplete. And finally, you check the year-on-year sales growth rate. Here it looks like you have something to celebrate. Your revenue went up by 4%. But intuitively, that also feels a little less to you because your company, you know, has been heavily investing in marketing, and 4% seems a little less in comparison to those efforts. If you put this together with the previous two learnings where you felt that there was something either inaccurate or incomplete, overall, you feel that this data, which otherwise looks like it's something to celebrate, seems like it's probably still misleading you in some way. You're now pretty sure that there is something off. In all of these cases, the common thread is that you are noticing something that doesn't make logical sense, and all of it probably has the same root cause. The differences that you are observing are meaningful, and if they're not resolved by you or by your team, then your company might end up making bad decisions. If it turns out that you actually made $500,000 extra in sales, maybe your company will decide to celebrate with a fun party instead of just some regular old cookies in the kitchen. So this is very important for us to figure out. Besides deciding how big our celebration should be, what would be the other reasons that we should care about bad data? Bad data, I believe, can be costly in so many different ways. And unfortunately, the more widespread the problems are, the worse those consequences get. First thing that it ends up doing is that it lowers trust. If bad data went unnoticed or unchallenged and then got presented out to someone who later learns that what you presented to them earlier was a mistake, that can be very damaging to your reputation. If you presented that data, maybe it was your peers, your boss, your leadership team. Sometimes it could be external, where it's the company investors or just the mass public. There can be a lot of consequences to that lower trust, and inherently that is expensive for you to fix. You could also end up losing real money. You can either directly lose revenue, or there is a cost inherently with the fact that you are now losing out on opportunities that could have led you down a different path. There could also be direct costs to fixing the bad data, which shows up in the form of extra expenditures that you have to invest in terms of time and effort. A big cost, unfortunately, is the harm that you can cause to real people through bias. If your bad data has some hidden biases, those can really cause people direct harm, and that is not sometimes just a monetary cost. It can show up in a lot of different ways. In some cases, you can actually even be held liable for some of these mistakes or for some of these things that were wrong. And depending on why something was wrong and what that incorrectness resulted in, you could have very high costs to pay. And finally, bad data is inherently just time consuming. It's painful to fix. It lowers the productivity of your data scientists, and it's also a big hit to people's morale. So data scientists, unfortunately, they end up spending a lot of time to fix bad data. First, they have to find an error. Then maybe somebody brought it to their attention, but all of it, they have to spend an effort figuring out, understanding what's going on. Then they have to actually communicate out the error, and they have to tell all the people who are concerned, all the people who would have taken a decision on that, especially if there's some time sensitive component that you don't want people to continue taking decisions. You have to communicate that out. And then you have to start hunting for the source, like where can I pinpoint why this is happening? You can start validating, you have to start cross-checking something. And there's a whole process of trying to QA whether you've actually found the discrepancy, whether it fully explains what happened, and whether you're in a position to move forward. Once you've identified that entire flow, you will actually go ahead and correct the issue and try to put a system in place that prevents it from happening again. And then lastly, you have to again communicate the fix. Even if the fault wasn't really caused by you, it is still your responsibility to actually communicate what happened, why it happened, how it will be prevented in the future, because your credibility and the trust that people have in you rests on that. So all of that, I feel, unfortunately, it can feel very tiring, and it can be a huge burden that data scientists have to carry. And people sometimes, I feel, leave jobs because their talents, they feel, are not being utilized optimally. If you are a data scientist and you feel that your company is not investing in trying to fix these issues that take up a lot of your time, that can make you feel undervalued. So what can we actually do about bad data? We can prevent it, we can diagnose it, and we can cure it. I'm going to spend a bulk of our time today at the prevent stage, because I truly believe that a lot of the understanding that we build at the prevention stage can help us with the later stages of diagnosing and curing it. So let's dive in and understand the prevent stage a little bit more and see how bad data actually gets introduced. So up close, we're going to take a look at the life cycle of data, because all data inherently goes through similar phases in a very sequential manner. So first step that we do is that we define the features and we align with different teams on those definitions. Next, we work on logging the data to track and store it. After that, we use some business rules to transform the data into a more usable format. After that, an analyst is able to interpret the data and solve some actual business problems. And finally, the data results are shared with actual stakeholders. And that, just to set the stage, is our data lifecycle. After we've identified the data lifecycle, you'll start to see that at each phase, there are actually numerous possibilities of how you can unintentionally introduce bad data. So I wanted to put this graphic. I will go through each section separately, but I wanted to show the full picture before we come back to it once more in the end. I actually tend to have this graphic pinned somewhere, somewhere I can access it easily, and it can help me prompt my head in a lot of things that I'm looking at. So let me jump into each of the sections, and we'll come back to this visual once more at the end. Also, heads up, a lot of my examples today will be anchored at the COVID-19 pandemic. Unfortunately, that is the theme of the world that we're living in right now. And I know things are starting to look up for the vaccine. So next year, maybe we can anchor our examples at something else. So let's say that you're trying to track COVID cases in a population. You're relying on data filled out per patient by healthcare workers. How would you define the various pieces of data that you want to track? A lot of issues can arise based on how specific or flexible you make that definition. So your feature definition may outline that to get a diagnosis for COVID means that they have to count as a positive case. But what about other people who were asymptomatic and never received a formal diagnosis? They would still test positive for antibodies, which means they did have the disease at some point. But now you're in a conundrum that should that trigger a case flag or not, because it doesn't meet your original definition. So COVID is an interesting example because it is a very widely reported disease, and everybody understands the importance of data in tracking this disease. So maybe there is wide consensus across different health professionals that with COVID, this is how we're going to track it. But that decision that you take with COVID might actually be very inconsistent with some other disease, and people might get confused when they look at some other disease and have this case of uneven logic, which is essentially creating bad data at the end of the day. Sometimes you can also end up having a very, very narrow definition that just doesn't include all the scenarios. So your definition includes the scenario for today, but it doesn't account for how that thing might change just a little bit tomorrow. This is something that's coming up with COVID as well, because there are some variants, for example, that are not being tracked the same way because we didn't plan for that. Sometimes it's just human error. Maybe your definition logic is actually correct, but there's a little typo that ends up meaning that a lot of people end up picking a slightly different disease with a few letters here and there. And these type of errors are actually, unfortunately, very common. Even with a bad definition, eventually what you're missing out on is seeing the clear picture. Your picture is either it looks oddly cropped out, or it's just not a picture of what you wanted to see in the first place. Next, we come to the logging stage, where you actually track the features that you have defined. Here also, there's a lot of potential for confusion and inaccuracy at this stage. So for example, your tracking itself could be incorrect. Maybe your engineering team is only logging a subset of the information, or unfortunately, maybe they're logging the wrong information. You might have been expecting that all COVID patients are being tracked, and instead now you just have COVID patients who have insurance that are being tracked, which, as you can understand, in the US healthcare system is a likely scenario. Maybe you were logging all cases with or without insurance, but you're logging them at separate places, and you're not able to reconcile that unintentionally. So in those kind of cases, again, there's some confusion that who is showing up in both those data sets. Were there some people who didn't realize they had insurance, and so they got tracked in one place, and then they showed up in the other place as well. All of that can be a little hard to sift through once you get down to it. Your pipeline itself, that's a very common place where there can be faults. There could be some exceptions where data is not being tracked. So for example, the healthcare worker is using their mobile app to fill out case details. And inherently, that is not a situation that you had planned for, because the tracking was set up for people logging stuff on the web. Or the pipeline could have also just broken, and it went unnoticed for some time, and now you have no way of retrieving that lost data. Another common problem is inconsistencies around time frame issues. So how long is the data being stored for? When does it get aggregated? What time zones are being used? All of that can cause problems, and people have a lot of assumptions that they make about time frame issues, which sometimes don't really fully show up. So ultimately, it comes down to the same thing, that if the connection is broken between the data that you want and the data that you are actually tracking, you are going to end up with a lot of unintended consequences. Next up, we have the transforming phase. So just like baking, if you are taking a bunch of rules and transforming raw ingredients to a finished product, a lot of mistakes can occur. With data, you need to take raw ingredients and convert it to something usable. Otherwise, every baker will create their own recipe and make a very different product. So let's look at the first part, which is, make sure that the rules that you have for your recipe or for your transformation are actually understood. When two humans look at a piece of data, they can inherently make a lot of different assumptions about what is there and why, what it represents. You're basically seeing a finished product like a cake in front of you, but you don't know what the recipe was, you don't know what the ingredients were, and you're going to try to take a best guess. Similarly, if someone has a table that they say they're putting out that contains per day the number of COVID cases, that's a finished product. But until you give them more context, people who are looking at that table don't really know what it represents. Does it represent new cases? Does it represent cumulative cases, or just all current cases where someone is diagnosed and hasn't yet recovered? So depending on what assumptions that people make when they look at something like that table, for example, they can end up using that data very differently downstream. And unless everybody uses the same policies for labeling data, there's going to be discrepancies that crop up. So data dictionaries are super helpful in this regard because they outline things in a way that is more easily understood and appreciated. How data is aggregated can also end up impacting how useful it is. If your data is not incrementally aggregated, then sometimes when there's an investigation, you have to go back up a couple of steps. Maybe there was like 5 transformations that you're doing in one step, and so you have no way of sort of separating it out. You go back to step 1, or you're stuck at your current step. And that actually inherently causes a lot of unnecessary work that has to be done. If you are in the beginning itself, if you're more thoughtful and aligned on the aggregations and about the specific use case that you're going to end up using it for, you can save yourself from a lot of endless data gymnastics, as I like to call them. Finally, you can have a lot of logical errors when you're transforming. Human error is something that shows up in every part of the data lifecycle, and transformation stage is not an exception. We're on our 4th stage of the data lifecycle, which is analyzing. And if you remember, there are 5 stages total. So this is where the rubber meets the road, and you start actively using the data as an input for key decisions. First step is the problem itself. Stakeholders and analysts can easily be misaligned on the inherent question that they're trying to answer. So, one person may think this is the question they're trying to answer, someone else may have a different assumption, and that misalignment can perpetuate, and it can lead to assumptions that are eventually expensive to fix. And it's demotivating if the analysis has already made a lot of headway by that point. There can be a lot of resentment and that builds up because of that, because of not having clarity on what problem was being solved. Besides that, while analyzing results, again, there's a capacity for human error if you use the wrong model to solve your problem or just make a mistake in your calculations. The last thing to watch out for is bias in your algorithm. So this is a very large topic, and I would almost consider it a whole talk on its own. But the thing that I want to highlight here is that the consequences of getting things wrong can be really intense. Especially if your industry is sensitive, if you work in healthcare, finance, housing, a lot of those type of things, there can be very dire consequences because of your biased algorithm. You can essentially have the capacity to negatively affect the disease burden of entire populations. And if you used a biased data set to learn about how a disease progresses, for example, and it only includes data points from a specific demographic, your published insights can actively cause harm to the underrepresented demographic that was not included in your original data sets. Unfortunately, there are a lot of very blatant examples of this in the industry. One of the most common examples is that women are more likely to die from a heart attack because their symptoms have not been well understood. And the lack of that understanding of their symptoms means there's poorer diagnosis, and it ends up with a very bad outcome. And this is due to the fact that in the early heart attack studies, women were not heavily included in that, so their symptoms never really got a chance to be understood. There are also differences along race, where Black women end up having a higher pregnancy-related mortality rate due to systemic racism that provided them inadequate and inferior care. Here again, the lack of data and research that would have quantified the problem led to this issue being ignored for decades, because Black women dying during childbirth was not seen and tracked in aggregate. Inherently, there's a lot of thoughtfulness required to make sense of data, and extracting the right insights at the analysis stage and not making an intentional error is very important. Again, you can make a lot of assumptions that maybe the incidence of breast cancer in men is ignored as bad data, but that's actually not the correct thing that you should do, because even if men have it at very low rates, it might still be relevant to your analysis. And maybe you end up throwing out useful data for transgender patients who are also historically underrepresented in optimized healthcare outcomes. Now we're up with our final stage of the data lifecycle, which is sharing it. So first up, I would like to draw your attention to this very real chart that was used by ABC about what worries people about COVID. There's a whole funky color scheme going on, which is 3 shades apart. Sounds like a great decision. And there's a pie chart that doesn't actually add up to 100%. It's a super pie with this extra 78% piece kept in there. When I first saw this chart, I actually had to go back and research that it actually existed because it was so bad. Sharing data is unfortunately a part where a lot of inaccuracies and misrepresentations show up. In general, people need to be very careful about the story that they're trying to tell and what they want viewers to take away from it. Faulty reporting includes data results that are just constructed incorrectly or have typos. And again, when you have that put out in the universe, it can start a whole cycle of faulty data, because people might do further analysis based on that sharing of data that is also inaccurate. And a good practice is generally, if you're not actively maintaining something, if something doesn't have an active owner, do archive it and don't share it for further bad decisions. Next thing to worry about is misinterpreted results. So again, COVID provides a lot of unfortunate examples here. Over the last year, I saw lots of examples of charts in very reputable sources that didn't even bother labeling their charts. There were sometimes missing keys or labels that were listed in a paragraph, but not in the chart, right next to the chart. So people who looked at it were missing some key context that would have made help them make better sense of what was being shared out. There's also a lot of cases where some raw numbers were being sensationalized, and they looked terrible until you normalize it by population size or some other factors. And some of these things can again have a lot of very heavy consequences, because there are policymakers, there are citizens who are reacting to that and making decisions based on stuff that they see. And if they're misinterpreting what is being shared with them, they'll make the wrong decision. Finally, a very common problem at this stage is that once you put stuff out there, once you give people access to data, they are free to use it for other analyses. And sometimes their use cases may not actually align with what the data is truly meant to represent. You can't, unfortunately, always stop people from doing that. But what you can do is that you can be thorough about outlining the nuances of the data that you're sharing and give some documentation that tries to prevent those unintended downstream use cases from what the data should and should not be used for. So that wraps up our prevent stage. Once again, keep in mind that there are a lot of different ways that we can introduce bad data. So this is not meant to be an exhaustive list, but rather a mind prompt to help folks easily identify the various things that you can keep in mind. Hopefully, once we understand how bad data gets created, it becomes a little easier to diagnose what's going on. So there are some very common ways that people take notice of bad data, similar to some things that I had shown in the beginning. So usually data has some source of truth. You look at two different things, they don't match either in absolute or aggregation, but there's some sort of misalignment. Other times you see something, it just doesn't make sense. It's not logical, and even if it ends up being eventually that it is the right answer, it will still warrant an investigation. Either ways, the first step is to look for the obvious reasons of why you are encountering or suspecting bad data. So the first question is it really bad data? Were those two numbers actually supposed to match, or were they always meant to represent two different things? And the suspicious results, what assumptions have led you to believe that there's something wrong there? After that, you should look at your data set and figure out, was it even meant for your use case? Or are you just looking for the answer in the wrong place? Finally, always try to verify if there is a known bug or a pipeline issue that can explain what's going on. And if there's a known fix or if the issue is temporary, like figure out what's going on with those type of things. So if none of the above reasons, sort of the very obvious reasons, if none of the above gives you an answer, the next step is to go very methodically, step by step, in trying to find the root cause. So here what I've done is I've basically taken the data lifecycle and flipped the order and started in reverse order. So what you're essentially doing is that at each phase, you are trying to verify if the phase before it has the right data. That can help you pinpoint exactly where in the lifecycle something is breaking. Next, you can also find, once you find that phase where the data is breaking, go through the common root cause examples and start creating some hypothesis about what might be happening. Hypothesize, test, and validate, and keep repeating that process until you find something that fully explains your issue. Final sanity checklist in the diagnose stage is to just logically go through your problem and document what you know and what you need to figure out. So my favorite thing is to go for the journalistic questions of when journalists are trying to document a story. They're basically looking at the what, where, when, why, who, and how of the problem. As I sort of go through this checklist, it helps to rope in other people to document my logic, to actually walk others through it, to look through data dictionaries, and all of that just so that I can start to validate some of my initial assumptions. And sometimes you might find discrepancies right there itself. In general, I think there is some truth out there. If you keep breaking down the problem, you can eventually find the very specific issue where something is going wrong. And finally, to our cure stage, once we have diagnosed bad data, hopefully curing it is a lot more straightforward. When you correctly identify the problem, the solution should ideally be straightforward. The diagnosis should tell you where the problem lies, and it's not always going to be in your hands to be able to fix it. Data lifecycle has many parts, and any of those parts could have an issue that has multiple owners, all of whom need to come together to fix it. So this is not something that only one person ends up doing by themselves. But also just, a healthy reminder, you can't always, unfortunately, fix every issue that occurred in the past. Sometimes something that broke can cause a permanent and unfixable gap that is known and that is expected. But you can try to at least cure the problem for the future. And you can try to create some sort of guardrails that flag those issues going forward. I also wanted to share a few concepts of a few common scripts that you can write to fix issues faster. It can result in a lot less data corruption. More familiar you are with your data, and the more you have an understanding of the common problems, it becomes a little easier to write common scripts or even make visualizations if that's how you better function to make issues easier to quickly pinpoint and fix. So one of the very simple ways is just do a volume check across different sources, especially when you're aggregating data. If you are able to compare the volumes of the raw rows that make up that data, that can immediately help you sort of narrow down what might be causing a problem. Things that help you quickly identify missing data or data that is duplicate are also very useful to quickly narrow down what it is that you need to fix. That, oh, it's just this specific row that got missed, or this group of rows which have a common attribute that got fixed or show up as a duplicate. And finally, just being able to break down the data by different dimensions can really help specialize, especially when the data is really large and individual queries are not going to be helpful. This is where I actually lean on a lot of visualization, because it's very easy to quickly see the drop. That overall maybe it looks fine, but when I break down issues by country, I suddenly see that US suddenly had this like little drop in this 1 month, and every other time it seems to be a high number. So those are things that can help you cross-reference stuff a little more easily. And if there's some backend automation that broke, like you can try to fix it. Finally, some coding practices that can help you stay consistent. So this is, I think, super important, but make sure that you try to write code only once, make it reusable, make it easily understood, and you should try to make it as plug and play as you can. You'll thank your past self when you're in a time crunch and you need to check a bunch of things in a short amount of time, that you'll have some ready scripts out there that you can deploy. Also, really just document your code, centralize it, make it easily accessible to others in your team, have other people use it for their problems, that everybody can sort of code review those type of things and get to a consistent outcome. And finally, this part is actually my favorite. As you know your data more, you'll have a better sense of what makes sense and what doesn't. So add alerts to your pipeline. Over time, you'll know what thresholds are normal and what should cause you to immediately launch an investigation before it even becomes a bigger issue. Last reminder, prevention is better than cure, just like health. There are a lot more detailed data lifecycle checklists that can help look at each phase and figure out, find ways of preventing bad data. But there are also some simple generalized strategies that I've listed here that can help very early on. So, make sure you're all speaking the same language, reconcile your terminologies, automate and simplify anytime there is a possibility to do that. Create a governance strategy. I think someone mentioned it in the chat as well, that have a governance strategy early on, and that will save you a lot of headaches at a later stage. Sometimes that's not possible in very small companies, but you have to keep incrementally making headway there. And finally, do an actual audit. Figure out what strategies and processes work for you, and have a way for folks to flag inconsistencies or anything that's broken. And with that, I wanted to leave you all with some additional research and reference material. You can take a snapshot and Google some of these things. There's a lot of great content about poor data quality out there, and COVID, unfortunately, presents a very large and publicly accessible data set that has plenty of examples of what to avoid. So I also have, in one of my other talks, I have specific coding examples as well, which is linked on my website. And finally, thank you so much for attending this session today. I really hope you found the content useful. And if you'd like to connect with me, I'm very active on Twitter. You can also find some additional ways of getting in touch with me on my website, shailvi.com. And thanks. And finally, I'd really like to thank the team of the Women in Data Science team for organizing this wonderful event and for hosting me virtually. We can now get to some questions. I'd love to hear from folks. I think there are some questions already, but if there are concepts that resonated or anything that you'd like to learn more about, please do share it. Thank you.
Thank you, Shailvi, for your talk. We'll now transition to Q&A. Shailvi, please see the Q&A tab for questions from the attendees.
Yes. All right. Okay, so I think Kelly said, awesome talk. Thank you. Do you have any thoughts on reputation recovery after finding bad data? if you've gotten to the point of reporting it to a stakeholder and then have an aha moment, how do you start addressing the inherent nobody trusts the data issues that reasonably come along? Kelly, this is a wonderful question, and I think my personal sort of opinion there is that trust is something that's built when you are also in a position where you admit mistakes, and I think that's actually healthy because people then believe that you're not selling them something that is not true. That hey, when there is something that go wrong, I trust this person to actually tell me that there was something that went wrong, and that way I'm not left guessing if something did or did not indeed go wrong. So I think the healthy way to do it is to talk about what happened, why did it happen, and what are you going to add in terms of a process or a best practice that's going to prevent something like that happening again. But taking ownership, I think is very important. But thank you for that question. Next question is, Next question is from Hope. Any tips for preventing unintended downstream use? This has been a huge problem in entertainment news, journalism, interpretation of data. Yes, absolutely. This is also very important because we can't stop people from what they decide to do with the data once it's out there. But I think, from our side, the best thing that we can do is document that this is what the data represents and this is what the data does not represent. So if you know of some obvious use cases that are going to be harmful, that you don't want people to use it, actually call it out like, hey, this data is not meant to make policy decisions about X, Y, and Z. And, I totally appreciate that the entertainment news and stuff like that, like they don't always do that. It's unfortunate because people end up making real decisions on that data sometimes, and it was never intended to be.
We have time for one more question.
Okay. So I see Samantha's question. What ways have you seen organizations and teams effectively incorporating addressing biases in data and predictive models, either pre or post-production? I think the most effective way, or I think a starting point, is to sort of do an audit. Like, first look at everything that is already out there and really think about who did you include in the data, who did you exclude from the data. Are there people who were not included in the training model data sets? Like, you have a population that is just very white and male, and so it doesn't truly represent all the people who will be using your product. And how do you actually start adjusting for that? So I think this is again, like it's a very meaty topic. I think there's a lot of very intentional ways, but just starting with an audit of who are we not including in our data, and who will get harmed by decisions taken on the basis of this data that who doesn't feel represented in it. Yeah, hope that helps.
You might actually have room for one more question.
Okay. I see Rachel's question. How can someone get experience with creating data pipelines? Dive right in. Try to find use cases that you're trying to enable. Think about what data you have access to and what should be the curated stage that you'd like it to get to, where it makes sense, where it is usable, and where it can actually help solve some problem in a simpler way. So just best way to get experience is to just find ways to do it and use that muscle a little bit.
Great. Thanks for the great talk, Shailvi. This concludes our session. If you have additional questions for our speaker, please send a direct message to Shailvi in Excel events through her Twitter or website, as I posted in the chat. We look forward to seeing you in the following sessions and the expo booths. Thank you, everyone.